Hey Precal, welcome to Pandemic Education, episode 5. Today we're going to be doing Unit 9, Lesson 3, Part 1. Let's get into it. Okay, so we are getting started with Unit 9, Lesson 3, Part 1. I've got a do now up. I would like you to pause the video and take a few minutes to solve this do now. You are solving the equation for the variable. When you're ready, resume the video and I will put the answers up. All right, so you should have gotten C for problem number 1 and you should have gotten D for problem number 2. If you have any questions about either of these problems, please make sure you bring it up to me during our office hours. So our objective, we're doing a lot of different things today. We're going to be talking about domain, range, asymptotes, end behavior, intercepts, intervals of increasing and decreasing, and most importantly, transformations of exponential and logarithmic functions. Today in part 1, we're just going to talk about exponential, and then when we do our part 2 video, we'll just talk about logarithmic functions. So I want you to take a second, and I want you to evaluate this function. Round your answer to 3 decimal places. Pause the video and attempt this problem, and then when you come back, I will talk about it. Okay, so you should have gotten that f of x at x equals 3.7 equals 0.0079. And when you round that to 3 decimal places, you will round it to 0.008 because that 9 in the 4th decimal point causes our 7 to round up to be an 8. There are a couple ways you could have done this. Personally, I would have just used my calculator and plugged in 3.74x in this exponent right here. Additionally, you could have chosen to graph this function if you're using a graphing calculator. And then when you do second trace, I believe it's option number 1 value, and you can just plug in the x value. It'll tell you what your function overall equals. So whenever we say evaluate and give you a specific value for x, you can just plug it into your calculator. Okay, so moving on. I know it's been a while since we've talked about transformations, so let's kind of go over them. Each of these pieces tells us something different about our graph. All right, the sign in front of our function on that a value determines whether our graph reflects across the x-axis. If it's a positive a value, there's no reflection. If it's a negative a value, my graph gets flipped over that x-axis to be either in the bottom quadrant or flipping up to be in the top quadrant. The sign on B will determine whether or not my graph is reflected across the y-axis. Remember, a positive b value means there's no reflection. A negative b value means that my equation flips. Now, the absolute value of a will tell us about vertical stretching and shrinking. So if the absolute value of a is greater than 1, my graph stretches upward. If a is between 0 and 1, so if a is a fraction, my graph gets compressed or shrinks vertically. Similarly, B talks about horizontal stretching and shrinking. Now, if B is between 0 and 1, my graph will expand and stretch horizontally, whereas if B is greater than 1, my graph compresses and shrinks horizontally. I don't know if you guys remember this, but remember we discussed outside same sign, inside op sign. So if outside the function, this a value is bigger than 1, it makes sense that we would get larger. But then when we go to the inside of the function, it's the opposite. So we would think it would stretch horizontally, but instead it actually compresses. It's the opposite of what we want to do. C and D values, I hope we're a little bit more familiar and comfortable with. So our C is a horizontal translation. And remember, we always need to write this so that our leading coefficient on x is a positive 1. And that's where we sometimes get a b value. You need to be able to factor this piece so that there's a 1, a positive 1 on that x value. So C is our horizontal translations. It tells us whether our graph shifts to the left or to the right. Sorry. So opposite sign. So if we have a positive C value, we're going to move to the left. And if we have a negative C value, we'll move to the right. Last but not least, D is our vertical translation, and it's the same sign. So a positive D value means we shift our graph upwards. A negative D value means we shift our graph downwards. Key pieces are to remember that B and C will actually be inside of our function, our parent function, and then A and D are outside of that overall piece. So today we'll look at exponential functions, and I'll kind of point out what's looking inside versus outside of our function. So what does our exponential base do? Because specifically today, we're talking about exponentials. All right. So our base, our exponential base cannot be less than 0. It will not be written as such, because what you can do with that, if it looks like it's a negative, that negative sign is really on your a value, okay? So that negative, like I said, it's really on the a value. It just means that we're reflecting across the x-axis. If our base is greater than 1, it looks like our regular standard exponential parent function. And if our base is between 0 and 1, we will be reflecting across the y-axis. So it's a little bit different, but let's say our base is 1/2 of x. We can rewrite this to say to say 2 to the -1 times x. And then this -1 is really a b value with a negative sign, which means we're reflecting across that y-axis. I know that logic might be a little tricky. Make sure you write these things down and definitely give this example for yourself in your notes. And if you have questions, please make sure you come to office hours. All right, so exponential functions have a variable in the exponent. We've got some examples and some non-examples. The key is that if there is not a variable in your exponent, it is not an exponential function. So an example, y equals 2 to the 3x minus 1. X is up here living in the exponent. A non-example, y equals 2x cubed. This is not an exponential function, this is a cubic function. Do we kind of see the difference? If you need to write down the rest of these examples and non-examples, please do so. But the key, if there's not a variable in the exponent, it's not an exponential function. All right, so we are going to look at this graph here and we are going to analyze all of these things in this big long list. This is our standard parent function for an exponential function. First thing we need to talk about is our domain. Remember, domain is at x's or y values. It's our x values. So we need to look, moving from left to right, what is the smallest x value we can possibly have? -infinity. What is the largest x value we can possibly have? +infinity. Both sides of my graph have those little arrows. So that means that my domain is from, let's maybe not do that. Hold on. I'm actually going to move to the document camera for this because that is not going to look good. There we go. Okay. So we've got our graph here, and I'm just going to kind of go through and we're going to answer all of these questions. So the smallest x value that we can have is -infinity, and it goes all the way to +infinity. Remember, infinity always gets its own set of parentheses. So now looking at this, what is the smallest y value we can possibly get for our range? Well, it looks to me like my graph is leveling out at y equals 0. So 0. And it looks again like we're going all the way up to +infinity. It's got that arrow pointing upwards going on forever and ever and ever. Now both of these are going to get parentheses. Because of this leveling out, I know we've got an asymptote here where my graph is going to get really, really close to it, but it's never going to actually touch or cross that line. So we've got an asymptote at y equals 0. Take a second, is this a vertical or horizontal asymptote? It's horizontal. Okay, our intercepts. If I've got an asymptote at y equals 0, I don't actually have an x-intercept, but we do have a y-intercept. We are crossing our y-axis right here at y equals 1. My end behavior, let's look here now. slide down a little bit. Okay. My end behavior. The limit as x approaches negative infinity, f of x equals. So as we go towards negative infinity, what is my y value getting closer and closer to? Getting closer and closer to that 0 value. Okay. My limit as x approaches positive infinity, f of x equals, well, as x gets larger and larger and larger, y is also getting larger and larger and larger. So I'm going to say infinity. Okay, last but not least are intervals of increasing and decreasing. So from left to right, is my graph, when is my graph getting larger? When is my graph getting smaller, etc. So all the way from the left and moving in, I'm getting bigger and bigger and bigger the entire time. So I'm actually going to say my intervals of increasing are from negative infinity to infinity. At no point moving from left to right did my graph ever start to decrease, right? My y values only grew, they never got smaller. So I'm going to say none right here. All right. I know that this is kind of a lot. If you don't have the ability to print out this notes and practice page that I have, please make sure you include it in your notes and sketch yourself a little graph to help you be successful as we move on analyzing more graphs. Okay, let's see, what was next? Okay, we're gonna do the same steps for more problems. Here we go. Again, I'm gonna do them on paper. So we've got 4 examples that we're going to do. I'm gonna do 2, and I'm gonna ask you to do 2 as part of your homework. So, looking at this first one, we are going to talk about all of the transformations that we see, and then we are going to analyze the function just like we did for our parent function. So the first thing that we're going to talk about, this a value out in front. I know it's an a value because it is outside of this piece that's got the exponent in it. So this is my f of x right here, and then this and this are outside of my function. So my a value is positive. Are we reflecting across the across the x-axis? No. So I'm going to write, I'll write here, no reflection over x. Okay. It's a positive 4. So are we going to stretch or shrink, and is it in the vertical or horizontal direction? We are going to be working in the vertical direction because we are outside of my function. Outside, same sign. This is larger than 1. I know we are going to stretch vertically by a factor of 4. Okay. Now we move inside of our function. The first thing we need to talk about is our base. Our base is 2. Going back to those base rules that you wrote down, which category is it? Is it less than 0? Is it greater than 1? Is it between 0 and 1? Well, 2 is greater than 1. So this base is just a regular parent function. We don't need to worry about any of that. Okay, moving on up into our exponent. We look for a b value. Is there a b value in this exponent? No, there's not. There's just a positive 1 in front of my x, so there is no b value. So no reflect over y, and we have no stretching or shrinking. Horizontally. Okay, now this -1 is a c value. So that means we are shifting horizontally. Because it is a -1, that means we shift to the right 1 space. Remember, inside opposite sign. It's a -1. You think we want to move to the left, but really we are moving to the right. Last but not least, this -3 on the outside is a vertical shift. And it's a negative, so we're going to shift down 3 spaces, 3 units. Okay. We've talked about each and every single piece here, and now we need to talk about all of these pieces. I don't know if you can see that, all of these pieces for this graph. So we will start with our domain. Did my domain change? Well, no, right? Because just because I shift sideways to the right, well, -infinity shifted to the right 1 unit is still going to be -infinity, right? So my domain is still -infinity to +infinity. Let's talk about the range, though. The range for my parent function was from 0 to infinity. But then I'm taking that and I'm shifting that whole thing down 3 units. So 0 shifted down 3 units is going to be -3. Infinity shifted down 3 units is still infinity. And if we look, we see that it looks like my graph kind of levels out, right? Right here at that -3, like there's an asymptote. Oh, wait, there used to be an asymptote for my parent function at 0 while we're taking that and shifting it down 3 units. So we've got an asymptote at y equals -3. Okay. I'm gonna slide this a little bit. Okay. Now we need to talk about our intercepts. Okay. Easiest one right now is I see we've got a y-intercept at -1. To find our x-intercept, we can do this one of 2 ways. You have graphing calculators, you can utilize those and find your x-intercept. Or we can say 0 equals all of this and then solve for x. Both are perfectly valid. Personally, I'm going to use my handy dandy graphing calculator because that'll be a lot quicker for me. Okay. Maybe it won't be. Hold on. Okay. So I'm going to graph this. 4 times 2 to the x minus 1. Oops. Minus 3. You can't see on this, I'm sorry. I'm gonna graph it and I'll let you know. We're doing a 0, remember bring it to the left, bring it to the right, hit enter, enter, enter. So our x-intercept is at 0.585. That's not a number I would have expected you to just get off the top of your head, but you could have used this equation and plugged 0 in for y to solve for it. Okay, let's talk about our end behavior. The limit as x approaches -infinity, f of x equals, oops. As x approaches -infinity, f of x approaches -3. Remember, we look at our range to figure out the limits. And then the limit as x approaches infinity, f of x equals +infinity. Last but not least, intervals of increasing and decreasing. This is once again a problem where we are only increasing, never decreasing. So I'm going to write increasing from -infinity to infinity. And I'm not even going to bother writing decreasing, because why? Why not? And that's it. We hit everything we needed to hit for this problem. It was a lot, but this is a really great analysis of this graph. So I know that it's a little sloppy, when you do this in your notes, hopefully yours will look a lot better than mine. I would recommend that you start off by writing your equation and a sketch of the graph. Talk about all of your transformations, and then do all of these pieces, okay? If you need to, continue to reference the notes and practice that I posted on Google Classroom for this lesson. So I'm actually gonna have you try number 4 as your assessment for this lesson. And I'm gonna move on and we're going to do number 5, and then you will do number 6 on your own. So here we go. Grab one that doesn't look like chicken scratch written all over it. Okay, number 5. So first thing I notice is that my exponential base has changed, and we are looking at a fraction. The next thing I see is that I have a negative sign all the way out here. What does this negative sign tell us? Well, it's a negative on an a value, which means we are going to be reflecting over the x. So I'm going to write that down. Reflect over x. Okay. I don't have an a value. It's a -1, so I don't have any stretching or shrinking in the vertical direction. Next, let's talk about our base. Our base is a fraction. So what does that mean? It's 3/5. So we reflect over our y as well. Okay, and if you forgot about that, that's where I would say reference those notes from the beginning of our lesson and about what the exponential base does. Okay, moving on. This whole thing, this x plus 1, is inside of my exponential function. So there's no b value. There's just this +1, which is a c value. Because it is +1, I know I'm going to shift left, oops, 1 unit. Inside opposite sign, and inside deals with horizontal movement, horizontal transformations of our function. Okay, last but not least, this +3. I know this +3 is going to deal with vertical translations, and because it is positive, I'm going to be moving up 3 units. Okay, we've talked about each of these pieces in our function, and now we can begin to analyze for domain, range, asymptotes, et cetera, et cetera. So, our domain. It's still going to be -infinity to +infinity. Just because I am shifting and reflecting, my graph is still extending way out and keeps going towards -infinity and keeps going this way towards +infinity. Let's talk about our range, though. Our range is a little different. So, because I reflected over my x-axis, I now see that it looks like my graph continues on towards -infinity as we move to the left. And as we move right, it levels out towards this horizontal asymptote, I'm sorry, at 3. Next, we need to talk about our asymptotes. There is an asymptote at y = 3. And we can dot it in and see that my graph is approaching that line and it will not cross it. Intercepts. Looking at my graph, because of this base and these reflections, I can see that it doesn't look like it crosses perfectly. So, easiest thing to do, if you want to find your x-intercept, you plug 0 in for x. If you want to find your y-intercept, you plug 0 in for y, or you can just use your calculator. That's what I'm going to do. So let me try this again. Negative. X plus 1 plus 3. Sorry, I'm just graphing. It's taking a minute. Okay. Using our calculator tools, we can do, ooh, if I tilt it, can you see it? No, sorry. Second trace, we'll do value, x equals 0, to find our y-intercept, and we get 2.4. To find our x-intercept, we do second trace 0, left bound, right bound, right? Bring it to the left of it, hit enter. Bring it to the right of it, hit enter one more time. And we get negative 3.15. And we'll leave it like that. Okay. Once we have found our x and y intercepts, we can talk about end behavior. Limit as x approaches negative infinity, f of x equals, well, as x approaches negative infinity, what's my graph doing? It's also going to approach negative infinity. The limit, however, as x approaches positive infinity, f of x equals 3, right? Look at your range to determine your limits in that end behavior of your function. Okay, last but not least, intervals of increasing and decreasing. I see that as I move from the left to the right, my y values are only growing, so I am increasing across the domain. You could have also written increasing and then said from negative infinity to positive infinity. It's the same thing. Both are acceptable. All right, so I've done 2 examples. I want you to do 2 examples. So look at problem number 4 and problem number 6 as your assignment for today. I will post a quick multiple choice assessment that I want you to do after you have attempted problems 3 and 4 on this page. But other than that, that's our lesson for today. We've talked about only exponential functions, so don't worry about the logarithmic functions on this practice page. Just do problems 4 and 6 before you attempt your assessment. And that's it. I hope to see you at office hours with any questions, and I hope you're all doing well, and I hope this was helpful. Love you lots. Talk to you soon. Bye.